Hi, welcome to 11.6 Graphs of Quadratic Functions. Hopefully by the end of this, you will be able to graph a quadratic function. You'll be able to identify the location of the vertex and its axis of symmetry, and determine the domain and range of the quadratic function. So, example 1, I want to show you guys what different things do to these quadratic graphs. So we'll look at what they look like, but also what some of these changes kind of do to it. So the first thing that I'm going to do is just show you what that x squared coefficient, what it does. So I'm going to have the functions f of x equals 2x squared, g of x equals 1/2 x squared, and h of x equals negative x squared. Okay? What I'm going to do is just create a nice little table of values. Okay? So I'm going to have an x value, and we're going to see for f of x what its y value will be, g of x what its y value will be, and h of x what its y value will be for each one. And we're just going to pick easy ones. How about -2, -1, 0, 1, and 2? Those should be nice and easy to graph. Okay? So my x value is -2. For f of x, I would do -2 squared, which would be 4. 4 times 2 is 8. We'll just keep going with f of x. If my x is -1, -1 squared is +1, and 1 times 2 is 2. If my x value is 0, 0 squared is 0, and 0 times 2 is 0. If my x value is 1, 1 squared is 1, and 1 times 2 is 2. If my x value is 2, 2 squared is 4, and 4 times 2 is 8. If you notice the symmetry right here, you know, there's your line of symmetry. For on either side, we kind of have mirror images. For -1 and +1, we have the same y value. For -2 and +2, we have the same y value. Let's see about g of x. So I have 1/2 x squared. So if x is -2, -2 squared is 4, and half of 4 is 2. If my x value is -1, -1 squared is 1, half of 1 is 1/2. If my x value is 0, 0 squared is 0, and half of 0 is still 0. If my x value is 1, 1 squared is 1, half of 1 is 1/2. If your x value is 2, 2 squared is 4, and half of 4 is 2. So again, we see that line of symmetry right down 0, where -1 and +1 have the same y value, -2 and +2 have the same y value. Last one, h of x is just the opposite of x squared. So we're going to do x squared first, and then take the opposite. So we'll do -2 for x. -2 squared is 4, and the opposite of 4 is -4. If x is -1, -1 squared is +1, and the opposite would be -1. If x is 0, 0 squared is 0, and the opposite of 0 is still 0. If x is +1, 1 squared is 1, and the opposite would be -1. If x is 2, 2 squared is 4, and the opposite would be -4. And again, we see that line of symmetry going through here. So now that we have a nice table of values, we're going to graph it. All right, and unfortunately you guys can't see everything all at once, but I promise I'm just graphing the same points that we have, that we just did, okay? So for f of x, we have the points -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. We can connect the dots to make a nice little U-shaped curve, which is called a parabola. So there's your first function, there's f of x. Okay, that was your 2x squared graph. The next one, for g of x, we have the points -2, 2, -1/2, 0, 0, 1, 1/2, and 2, 2. And let's see here, we have a much wider looking curve on this one. Okay, so it's still a U shape, but it's much wider looking, okay? It's not so narrow. So g of x was 1/2 x squared. Then we have h of x, so we've got the points -2, -4, -1, -1, 0, 0, 1, 1, and 2, -4. So we notice that that opposite of x basically flips it upside down. So here's our h of x function. which was negative x squared. So we can see what those coefficients do. If it's negative, our parabola is going to go down. If it's positive, our parabola is going up. Higher values of a make them narrower, and lower values of a, like something less than 1 especially, like between 0 and 1, make them a wider graph. Okay? Let's do some more. Example 2, what we're going to look at now is what if we add or subtract something from that function? Okay? What does that do to our graph? So I've got f of x equals x squared plus 3, and I have g of x equals x squared minus 2. So I'm just taking that regular x squared graph, and I'm going to see what happens if I add 3, what happens if I subtract 2, what changes does that make. So again, I'm going to make a nice little table of values. Got my x values, I'm going to do f of x and g of x and make a nice little table. I'll use the same x values, those worked out pretty nicely, negative 2, negative 1, 0, 1, and 2. And I'm just going to substitute those in. If I use f of x, if x is negative 2 squared is 4, 4 plus 3 is 7. If x is negative 1 squared is 1, 1 plus 3 is 4. If x is 0, 0 squared is 0, and 0 plus 3 is 3. If x is 1, 1 squared is 1, 1 plus 3 is 4. If x is 2, 2 squared is 4, and 4 plus 3 is 7. And so yet again, you see that symmetry along that 0 line, okay? For g of x, we have x squared minus 2. If x is negative 2 squared is 4, 4 minus 2 is 2. If x is negative 1 squared is 1, 1 minus 2 is negative 1. If x is 0, 0 squared is 0, 0 minus 2 is negative 2. If x is 1, 1 squared is 1, and 1 minus 2 is negative 1. If x is 2, 2 squared is 4, and 4 minus 2 is 2, and we can again see that line of symmetry. Okay? Now that we have a nice little table of values, let's go to graphing it. Okay? So, for f of x, I had the points negative 2, 7, negative 1, 4, 0, 3, 1, 4, and 2, 7. So you'll notice it makes a nice U shape. It's not quite as narrow as that x squared, not as wide as the 1/2 x, or sorry, 2x squared and 1/2 x squared. It's the same shape as a y equals x squared graph, but it moved up 3. Okay. That was f of x. F of x equals x squared plus 3. For g of x, we've got the points negative 2, 2, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, 2. So again, it's the exact same shape as we have above, so this doesn't make it wider or narrower. What it's really doing is shifting that graph up or down, okay? So here's my g of x equals x squared minus 2, and you'll notice the vertex here, instead of being at 0, 0 like we had with x squared, it was 0, 3. And this one, instead of 0, 0, is 0, negative 2. So it's literally that plus 3 is shifting the entire graph up 3, and this minus 2 is shifting the entire graph down 2. Okay. Next up, in example 3, we're going to see, well, what about if we change things inside the parentheses, inside that squaring function? Okay. So we've got f of x equals x minus 2 squared. And we're going to have g of x equals x plus 3 squared. Okay? And for this one, when we make that table of values, it's going to look a little bit different because they kind of shift things around a little bit more with our x's. So I'm going to use a slightly wider range, okay? So that we can graph things a little more easier. So I'm actually going to start down with negative 3. Negative 2, negative 1, 0, 1, 2, 3. Just so we can get to where we need to be, okay? So if x is negative 3, in that f of x function, you'd have negative 3 minus 2, which would be negative 5. And negative 5 squared is going to be 25, which is way too big to fit on our graph, okay? If x is negative 2 minus 2 would be negative 4, and negative 4 squared is 16, another one that's too big for us to try to fit on our graph. If x is negative 1, we'll have negative 1 minus 2, which is negative 3, and negative 3 squared is 9. That's better. If x is 0, we'll have 0 minus 2, which is negative 2, and negative 2 squared, which is 4. If x is 1, we'll have 1 minus 2, which would be 1, or negative 1. Negative 1 squared is 1. If x is 2, 2 minus 2 is 0, and 0 squared is 0. And for 3 minus 2 is 1, and 1 squared is 1. And so what you'll notice with this one is we didn't start going back up again till right here. There's your line of symmetry. And it happened at x equals 2 instead of at x equals 0 like everything else had. And that's because this one's shifting it to the right too. So let's look at g of x. Same things. If I have negative 3 minus, or negative 3 plus 3 is 0, and 0 squared is 0. If I have negative 2 plus 3 is 1, 1 squared is 1. If I have negative 1 squared, or negative 1 plus 3 is 2, 2 squared is 4. 0 plus 3 is 3, 3 squared is 9. We're just getting bigger at this point, aren't we? 1 plus 3 is 4, 4 squared is 16. 2 plus 3 is 5, and 5 squared is 25. 3 plus 3 is 6, and 6 squared is 36. And you're like, well, we never bounced back. Well, it helps. We could also just do negative 4, just to kind of see, what happens on the other side. These just kept getting bigger. You can always see more, okay? If you negative 4 plus 3, you would get negative 1, and negative 1 squared is 1. And so we finally see that you have that symmetry right here at that 0, but it happened at x is negative 3 because that x plus 3 is going to move it over. It's going to shift it to the left 3. Okay, so we have a lot of points, and some of them have larger values than are going to fit on our graph, but we're going to fit on our graph whatever we can, okay? My graph paper just goes from negative 10 to 10. So for f of x, the first one that's going to fit is the point negative 1, 9. Then I've got 0, 4, 1, 1, 2, 0, and 3, 1. And you can probably guess what the rest of it looks like. That's the nice thing about us understanding that these have symmetry, is if this is my line of symmetry through x is 2, you can literally make mirror images. You're like, well, this one was 4, it was 2 away from that line, so if I go 2 away on the other side, there should be another point identical to it. It's like a mirror image. Well, here we have a y value of 9. It was 3 away, so if I go 3 away on the other side, there's another point right there. And so you can actually fill in the rest of your graph just by knowing that there's symmetry there. Okay? So that right there is what our f of x equals x minus 2 squared, what that graph looks like. Okay? For our g of x line, let's go ahead and use that point. Negative 4, 1, negative 3, 0, negative 2, 1, negative 1, 4, 0, 9, and then everything else got too big. But again, if you want to use that symmetry, you totally can. The symmetry, you can kind of see where it went down and then back up again. That point is called the vertex. And so if you want, you can make those other points, okay? So we could put a point here and a point there, and make a nice parabola U shape. And there's your g of x equals x plus 3 squared graph. And you can see how this shifts it to the right 2 and that one to the left 3. So I have a small summary of basically those a values and those x squared values, and how it moves up, down, left, or right. And now you guys get to try one and show me how much you've learned.